Welcome class. Thank you for joining me for 6-5. Today we're finally going to dive into actually solving square root equations. However, we're also going to include other things higher than square roots. We're going to deal with cube roots, rational expressions, all that fun stuff. So, the steps to solving any radical equation is hopefully you remember from Expo. The first thing we're going to do is isolate the radical term. We need that radical term by itself. Once we do that, we're going to raise both sides to the power of the index. Now, what I mean by that is if you're dealing with a square root, you square both sides. If you're dealing with a cube root, you cube both sides. So pretty logical, something I believe will make sense to you. Then once you do that, your third step is solve the resulting equation for x. Then finally check your answer to make sure it works in the original equation. So let's just dive into the first example. So the first thing we're always looking for is to isolate the square root, getting the square root by itself. However, when you look at our first example, you see this 3 here. Well, I'm going to subtract it from both sides because again, the goal is we want that square root by itself. All right, so I have my square root by itself. So what am I going to do? Well, I'm going to square both sides now. It is a square root. So I'm going to square both sides. Well, squaring a square root basically erases the root. So all I'm left with on that side is 2x minus 3. And then 5 squared, well, that's just a number. That's just going to give me 25. Now I'm ready to solve this linear equation. So what can I do? Well, I can add 3 to both sides to get 2x equals 28. And then I can divide both sides by 2 and get 14. All right, now, it says the fourth step is always checking your work. It's always a good idea to make sure your answer actually works in the original problem. So I'm going to put in that 14 for x. So we would have 3 plus, well, 2 times 14 is 28, minus 3 is 25, equals 8. Well, 3 plus 5 does equal 8. So checking our answer, it does work in the original equation. We have truly solved this problem. So let's take a look at the next one, shall we? So recall our very first step, we're going to isolate the radical expression. Right now I can see that the radical expression is being multiplied by 4. So I'm going to divide both sides by 4. So I'm going to get x minus 5 and 2 over there. Well, now looking at this, now my radical is isolated. I have it by itself. Now remember what I said. When we're looking to get rid of it, you have to raise both sides to the index. So here, the index is 3. So I have to raise both of these to the third power. All right, so just like with the square root, when you raise a cube root to the third power, all it does is erases your root. Your root is now completely gone. And then 2 cubed. Now here, don't be that kid that tells me still that it is 6. 2 cubed is 8. Now I have a linear equation I need to solve for x. So I'm going to add 5 to both sides to get x equals 13. Now, once again, that final step, let's go back and let's just make sure that it makes sense. Let's make sure that this works in the original equation. So I'm going to have 4 times the cubed root of, well, x minus 5. 13 minus 5 is 8. So let's see, cubed root of 8 is 2 times 4 does, in fact, give me 8. So once again, this checks out, and we actually have found our answer. So please make sure you have all this written down before I move on to the next slide. Because on the next slide, we're going to start something brand new for you, okay? So all of these rational expressions we've been working with, rational exponents, well, now we're going to have a little rule, all right? So if you're looking at an equation like this, So x to the m over n. And that equals anything, a number, whatever. The way that you get rid of that is you're going to raise both sides to the reciprocal of that fraction. So you're going to flip that fraction. Well, why does that make sense? So remember, power of a power means you would multiply exponents. So here they're showing you what this looks like. So if you have m over n times n over m, the result just gives you 1. And if you have an exponent of 1, you don't have any radical, you don't have anything. So that's why this process works. It's because taking it to the power of the reciprocal, basically what you're doing is you're canceling out everything. Okay, there is going to be no power left because you're going to have a 1. So let's try it out. So the first thing I want to do, I need to isolate the square, or not the square root, I need to isolate the rational expression, all right? So I'm going to divide both of these by 3. So it's the same idea as with that radical, okay? You need to isolate that expression first. So now what are we going to do? Well, now I'm going to go to this step. I'm going to raise both things to that reciprocal power. So reciprocal power, reciprocal power. So what does that do? Well, it cancels off that one. Now, 4 to the 3 halves. Now, we've practiced this before. So remember, take the root piece first. So the fact that it is a half there, well, the square root of 4 is 2. Then focus on the cube. So 2 to the 3rd power leaves you 8. Now there is one more little hiccup that I need you to know. All right? So here, if m is even, so if the top of that original rational exponent is even, you are actually getting absolute values there. All right, now the reason for this is because when you take the even root of something, you're getting a plus or minus. Well, kind of the same thing here, okay? We're taking basically a root of it, so we have to consider absolute value. Now, if you remember for absolute value, that gives you 2 equations, the positive equation and the negative equation. So we'll get 2 solutions, x equals 7 and x equals negative 9 here. Now I realize for this first example, this is a lot to digest, okay? So just take a moment, make sure you have it all written down. Note any questions you may have. If you don't understand why I just did something, make a note of it so you can ask me in class, because I realize that these examples are going to be kind of a lot. Now, our next example is going to be a little bit better. So, first things first, we're going to isolate that term. So I'm going to divide both sides by 2. And now, just like before, I'm going to raise both sides to that reciprocal power. So this time, 4 over 3. So what happens? Well, it cancels that all together. And then 8 to the 4/3. So again, focus on that root first. So the cubed root of 8 is 2. Now, 2 to the 4th is 16. And now I want you to think. So this only happens when that original rational exponent had an even number on top. So if you look at this one, well, we started with a 3 there. So this time we're okay. We don't have to do absolute value. We're completely fine without it. All we have to do is finish solving. So add 1 to both, or add 5 to both sides, and you get x equals 21. So again, a little bit nicer of an example, but the only thing that's different is that absolute value, which again only happens when your original rational exponent has an even number on top. And again, please note any questions that you have, because I will be more than happy to answer all of your questions during class if there's anything still confusing after these notes. So let's scroll down. For meteor crater in Arizona, the formula d equals 2 times the cubed root of v over 0.3 relates the diameter d of the rim in meters to the volume. And then you want to know, what is the volume of the meteor? So the first thing that I'm going to note is d needs to be in meters. Well, right now, they're giving us kilometers. So before we even start dealing with the formula, we need to change that. So we have, and I'm going to change color to make it easier to see. So we have 1.2 kilometers. Now, how many meters go into a kilometer? Well, 1,000 meters per 1 kilometer. And again, how did I know how to make that transition? Well, the first thing to know is kilo means 1,000. And then how did I know where to put it in the fraction? Well, because I need those two things to cancel out. So I'm going to be left with 1,200 meters. So those two things are equivalent. That's the number we're going to need to use because the formula only works for meters. So let's plug that in. So I have 1,200 meters All right. So this is going back to our radical examples. So first we need to isolate that radical term. So I'm going to divide both sides by 2. Now that I have the radical term by itself, I'm going to raise both sides of this to the 3rd power, because that's how you cancel a cubed root. So 600 to the 3rd power is, let's see how many zeros that is. 1, 2, 3, 4, 5, 6 zeros. And remember that erases your cubed root. All right, so that is a huge number. Now, let's take a look. If I want V by itself, that volume by itself, well, now it's telling me I need to multiply by 0.3 to get rid of that. And that's still going to leave me with a really large number, though. 3, 4, 5. And this is in cubic meters. All right, so again, same steps as we did before. You isolate the radical term, raise it to the proper power. Here, at this step, now I needed to solve the linear equation. Well, that meant by multiplying both sides by 0.3, and then that gave me my answer, which is a very large number. However, it makes sense because the volume of a crater would be a big number. So that is going to be all for today. I think that is enough examples for you to focus on. So before you stop watching, please make sure you have all these notes taken, and then come back ready for some practice work in class.